What is NSTU? Novosibirsk State Technical University is one of the largest technical universities in Russia, located in the very heart of the vast Siberian region. It might be called a city within a city, not only because of its size and infrastructure, but the special rhythm of life influencing emotions of thousands. NSTU guarantees advanced education, offers a vast variety of programs, and is proud of its highly qualified faculty. It provides stimulating ground for the students to acquire knowledge, develop skills, and understand the beauty of the world in its diversity and multiplicity. NSTU is innovative and research-oriented. It is a place where breakthrough discoveries are made to contribute to intellectually challenging fields of study and world-class scientific projects. NSTU enjoys freedom of creativity and thought. It offers both students and staff the opportunity to express themselves, to maximize their talents and give way to imagination. It allows them to get surprised and surprise the world, broadening horizons and seeing new things in what seemed only common and ordinary. NSTU is born to be a winner. Its faculty does their best to educate high achievers who understand that soaring to new heights involves strategizing and hard work. The desire to win is the first step on the way to success. NSTU is your career. It offers new contacts leading to lifelong friendship, positive emotions, and love. It fills your life with meaning and gives unforgettable experiences. NSTU is people. NSTU is you.
Более 20 лет назад конференция, а точнее школа-семинар, была организована профессором Гритчиным Виктором Алексеевичем и его коллегами по кафедре, а также учеными Института физики полупроводников Сибирского отделения Академии наук.
More than 20 years ago, this conference, actually school seminar, was organized by Gritchin Viktor Alexeyevich, his department colleagues, and scientists from Rzhanov Institute of Semiconductor Physics, Siberian branch of Russian Academy of Sciences.
Главной идеей конференции было привлечение молодых, только что вступающих в научную тропу исследователей. На пленарных секциях выступали известные ученые, рассказывающие о своих достижениях, направлениях развития науки и о последних открытиях.
The main idea of the conference was attracting young specialists who just began their scientific way. On Plenary Session, famous scientists made reports about their achievements, told about directions of scientific development and recent discoveries.
Сегодня считаю необходимым вспомнить о замечательных докладах члена-корреспондента Российской Академии наук Игоря Георгиевича Неизвестного, который на протяжении более 15 лет знакомил молодое поколение науки с историей и развитием научных направлений в физике полупроводников.
Today, I feel obliged to remember about great reports made by Igor Grigorovich Neizvestny, corresponding member of RAS, who introduced young people to science with history and present state of semiconductor physics during 15 years.
Следует отметить, что главная идея конференции сохранилась на протяжении 21 года, и хочется выразить надежду и уверенность, что так будет и далее.
It's worth noting that the main idea of our conference remained for 21 years, so I hope and believe that it's gonna stay that way.
Очевидной была направленность конференции. Она определялась научными интересами ее создателей.
The focus of the conference was obvious. It was determined by the scientific interest of the organizers.
Жизнь вносила свои коррективы. Количество секций постепенно увеличилось, а также увеличилась география участников конференции. Одними из первых к участию в организации конференции присоединились наши коллеги из Сибгути, если позволите, сокращенно, из Бийского технологического института, Томский политехнический университет и из Тусура.
Life makes its own judgments. The number of sections increased. Also, the geography of the participants brought up. Our colleagues from SIB-SUTIS, BTI, TPU, and TSUSR were the first who participated and organized this conference.
Сегодня, как и ранее, наши конференции проводятся под эгидой Института инженеров, электротехники и электроники, IEEE. Организатором конференции сегодня является сибирская секция IEEE.
Today, as in the past, our conference is held under the auspice of the Institute of Electrical and Electronics Engineers, IEEE. The organizer of our conference is Siberian section of IEEE.
Учитывая сегодняшние тенденции научно-технического развития, а именно внедренческий бум информационных технологий, повсеместную цифровизацию, весьма важным для нас является то, что ключевым отраслевым партнером 22-й конференции является известная компания Huawei Technology Company.
Considering current trends of scientific and technical developments, in particular innovational trends of information technologies and digital masses, especially significant for us, became the key industrial partner of 22nd conference. It is known company Huawei Technologies.
Партнерами конференции сегодня являются Новосибирский государственный технический университет, Новосибирский государственный университет, Сибирский государственный университет телекоммуникаций и информатики, Институт физики полупроводников имени академика Ржанова Сибирского отделения Академии наук, Бийский технологический институт, это филиал Алтайского государственного технического университета, а также компания Keysight Technologies.
As well, the partners of our conference are NSTU, NSU, SIB, STIS, Rjanov Institute of Semiconductor Physics, Siberian branch of Russian Academy of Sciences, Biysk Technologies Institute, branch of the Altai State Technical University, and the Keysight Technologies Company.
В этом году конференция будет проходить фактически в 11 секциях. Их стало больше. Мы надеемся, что они станут традиционными, и количество партнеров перерастет количество в качество нашей конференции, вырастет уровень признания и популярности.
This year, our conference contains particular 11 sections, more than before. We hope they become traditional and number will grow into quality of our conference, and its recognition and population will also raise up.
Следует отметить, что впервые ЕДМ стала площадкой для проведения конкурсов молодых профессионалов.
In this year, EDM became a platform of young professionals.
Впервые в рамках конференции появляется гуманитарный блок. Это секция истории и перспективы развития информатики и электроники в контексте решения гуманитарных проблем общества.
For the first time in our conference appears humanitarian section, history and prospects for the informatics and electronics development in the context of humanitarian problems of the society solving.
Создавая такую секцию, мы исходили из того, что наши молодые ученые должны быть людьми всесторонне развитыми, культурными прежде всего. Поэтому гуманитарный аспект, полагаем, весьма важен в образовании молодого ученого.
This section was made because we think that our young specialists should be comprehensive and cultural people. Therefore, the humanitarian aspect is very important in the education of young researcher.
Открывая конференцию от имени оргкомитета, желаем всем приобрести новые знания, оценить свой уровень исследований, приобрести друзей и, безусловно, хорошо отдохнуть. Спасибо.
And now, on behalf of organizational committee, we open our conference and we wish you to acquire new knowledge, assesses your level of research, find friends, and of course have a good rest. Thank you.
Уважаемые коллеги, теперь приступаем к основным, вернее, сначала еще раз к приветственным докладам, а далее к основным докладам. Слово предоставляется Василию Борисову. Его доклад, его сообщение на тему об институте, от IEEE, извините, пожалуйста.
The next speaker is Vasilii Borisov, the Institute of Electrical and Electronics Engineers.
Dear colleagues, good day. On behalf of IEEE Russia Siberia section, as chair of Russia Siberia section, I greet the participants and volunteers of the International Conference of Young Professionals in Electron Devices and Materials. This is one of the oldest and most respected conference held under auspice of the Russia Siberia section. This event is unique opportunities to unite young and senior scientists in a relaxed atmosphere in the Altai Mountains. It is a great honor for me and my colleague to be here and speak here in front of participants and organizers. Thanks a lot for your invitation. Unfortunately, I have to start with very sad news that came us from Moscow. On June 20, our colleague and close friend, Roman Yurievich Ivanushkin, passed away due to severe coronavirus infection. Roman Yurievich was a long-time director of branch in Moscow under IEEE Worldwide Limited. He was a highly qualified specialist and honest and worthy person. We know Roman Yurievich for a very long time, and he served as director from the creation of the old branch and through the transition of the new branch. A few years later, he worked very closely with the branch chief account and very committed to ensuring the branch always complied with the regulations from the authorities of the Russian Federations. We will always grateful to Roman Yurievich for his services and dedication during all these years. He will be very much missed. I declare a minute of silence in memory of Roman Yurievich. Thank you. As the chair of Siberia section, I call to everyone to get vaccinated. As the health and safety of our members and volunteers is number one priority of the IEEE. But what is IEEE? I hope everyone present knows, but just in case, I will tell you a little more. The Institute of Electrical and Electronic Engineers is a professional organization which provides the latest technical knowledge of members through conference, journals, workshops, and continued education for advance of technology for humanity. The main advantages of becoming a member, if some reason, if you are not a member, of course, firstly, gain expertise and open career doors. IEEE houses an unrivaled network of professionals, experts, and advisors can help more shape your career, offer resources, and acquire new skills, advance your professional development, and provide numerous opportunities for involvement, recognitions, and reward. Secondly, stay current and get ahead. Membership grants you access to largest library of electrical engineering, computer science, and electronic technical literature, as well as the latest technology trends, industry news, and events. Build a network, collaborative with IEEE colleagues and member groups online and in person. Build a support group for your professional, industry, or project with more than 400,000 members in more than 116 countries. IEEE is the world's largest technical professional society. I think you know about IEEE Explorer, the full text access to IEEE transactions, journals, magazines, and conference proceedings published since 1988 at all current IEEE standards. You can find IEEE geographic structure. Has a rather complex structure. I will tell a little more about this structure. A member of IEEE automatically became member of their local IEEE section, for example, Siberia section. Allowing them to share technical, professional, and personal interests with other of the worldwide member community of IEEE. Section consists of chapters, shall be a technical subunit of sections or a geographical councils. They may be a single society chapters or maybe joint society chapters. The available resources are available from IEEE and its 38 technical societies. An affinity group is a non-technical subunit of one or more IEEE sections. The following types of affinity groups within IEEE, for example, consultant network, life member, women engineering, and of course, young professionals. Wherever you live, there's a good chance there is an IEEE meeting near you. You can see all regions around the world. View the IEEE regional world map and follow the link IEEE.org. You learn more about your region and IEEE geographic unit, for example, section, chapter, and affinity group, activity with your region. IEEE society members stay technical current, network with colleagues locally and abroad, and collaborative on research. You can see technical societies of IEEE, and you can find your scientific interesting areas in these societies. IEEE Russia Siberia section was established on February 2003. Section has the strong potential for membership growth of cities from Ural to Far East. The area includes 7 time belts and length more than 5,000 kilometers. The Siberian section has a number of awards for development of IEEE community. You can see on the slide. Something about us. Grigory Khazankin, our treasurer and IEEE evangelist, will came this today. Our secretary Viktor Chechotkin, please hand up. Our vice chair is Anton Dolganov. and me, please feel free to ask some questions about IEEE during all conference. You can see some units of IEEE Russia's Siberia sections. Chapter provide society members with valuable opportunities to network at the local level, enabling their potential and professional growth. I will tell a little more about our leading conference to be held every 3 years. CyberCon, the flagship multi-conference of the sections. CyberCon was held with collaboration with ISOC Russia Siberia Russia chapter with Huawei Technologies, AK industrial partner. Annual IEEE Ural-Siberian Conference on Computational Technologies and Cognitive Science, Genomics and Biomedicine. This conference will provide an interdisciplinary platform for discussing problems on cognitive science, genomics, bioinformatics, computational modeling in physiology and medicine. The next conference is USB Read. The purpose of USB Read is bring together researchers and practitioners from multiple areas of science, including biomedical engineering, radioelectronics, information technologies, and other. And about EDM, I think you can, I can now launch a talk. Everything has already been said, of course. And at the end of my speech, I would like to say a few words about the section rules introduced this year. All conference organizers undertake a commitment to place following URL and can find our rules. Several points about authorship and publication policy. You can see on the slide. And if you have any questions, please contact us or find us in social network. Thanks a lot. Good day.
Thank you very much.
Уважаемые коллеги, прежде чем мы приступим к техническим докладам, мне бы хотелось сделать небольшое отступление. Ну, прежде всего, хочу напомнить, что в той ситуации, в которой проходит конференция, живет страна и весь мир, я призываю всех носить маски. Это первое, что хотел бы сказать. Далее, наш оргкомитет провел достаточно большую работу, и все, кто присутствует сегодня на нашей конференции, хочу заверить вас, никто из них не имеет не только ковида, но и ОРВИ. Будьте уверены, что присутствующие здесь все люди являются здоровыми, но маски носить все-таки необходимо. Спасибо. вашего позволения, приступаем к техническим докладам. Я хочу предоставить слово Игорю Пункову. Благодарю. Актуальные проблемы беспроводной и оптоволоконной связи.
Today I'd like to say about actual problem in fiber and wireless. No, you see, this is only a small part of our research.
Use microphone,
Okay, of our research, and later I will say about more details and so on. And now I will concentrate of problems of wireless and fiber in Moscow R&D Center. This is only part of our research, but you see, unfortunately, not all. Is it possible to shrink or maybe shift a little? Сдвинуть можно немножко, чтобы помещалось все на экран. Мне кажется, проектор нужно немножко пододвинуть, что не помещается на экран.
Вот стоять и двигать. Повернуть его.
Назад. Или наоборот вперед. Да, вперед, наверное.
Now we will try to do it.
We start from customer. And customer, this is you really. And for you, it's most important, very simple things like weight, size, power, efficiency, capacity, and bit rate of your mobile phone and base station. And this support wireless first of all and optic. And here it is, we have many technical problems like power amplifier, antenna. Немножко опять уезжает.
Excuse me, please, you can join to our Zoom channel. There you can see this presentation, the very good picture of this presentation in Zoom.
Okay, and this technical problem follow for very hard mathematical problem. Here it is, I write it, later I will stop in more details. And что-то он как-то заторможенно переключает. Okay. Here it is, you see structure of our mobile base station. We develop it and so on. It includes antenna, RRU, and BBU. And RRU include duplexer, power amplifier, and digital control, and so on. And BBU, I will concentrate later. And you see this part is very big, and you can see it in every for example, Punkov. Now it's very many. And you see the structure of this equipment is antenna, duplexer, power amplifier, and we design, for example, antenna designer, and if here it is, specialist in this area, we will be very happy have contact and contract with you. After that, filter design, very important part, because third of this equipment, this is duplexer. It's very big. Power amplifier and high efficiency controller with predict or correct non-linearity of power amplifier. This is digital predictor. and we have ASIC optimization problem, and you see now it's very, very important problem for Huawei because of United States sanction. We have very high limited in this area because previous, you know, Huawei produce ASIC and mobile chip for mobile in Taiwan. This is best piece fabric which produce 7 nanometer technology. But now it's forbidden, so Huawei really have very, very hard problem. And if you will help us solve this problem, it will be excellent. No, I will stay. It's a little later. Потом как-то заторможено.
Через Китай идет.
Через Китай идет.
I will help you.
Нет, может, мощность. Да. Я нажимаю. Крепко. Не. Только в ваших руках.
Yes.
Ну, это, да?
Yes.
Я надеюсь, жму. Да. Нет, только в женских руках это может работать.
I can help you to do this.
Ну, first of all, I concentrate on
Давайте мы Марии поручим.
system problem in wireless. Next slide, please. Нет, не только вы. Here it is. First of all, you see this is traditional system of base station communicate with mobile, and in the border of two sectors is very hard problem because cells communicate with each other. Communicate with each other not very good, and big problem for us organize such a nanostructure. Another structure, okay. Thank you. Another structure which will add each other, and this is system problem. And again, if you can help us solve it, it will be excellent. Another problem you see now every mobile communicate with personal base station, and new approach is when mobile will communicate with each other. This is how to say, need new protocol, new system of communication, and so on, and have many problems. Вот этим, да? Там у меня батарейка просто самый сел. Значит, туда. Следующий. Ага, спасибо. This is software model-based performance analysis method, which need to increase. Здесь тоже есть эта штучка. Вот есть, отлично. Which increase bitrate of mobile communication system, and this is problem 2. Next, this is transceiver problem, receiver and transmitter. I repeat this slide again, and this is problem of this equipment, RRU. First of all, this is antenna problem. You see now mobile system and your mobile is multi-band system. Now it works usually in 2 bands, but in future 4 and more bands. And you see problem of antenna is very very hard here because, for example, this is high frequency antenna, this is low frequency, and it's stand one by one. And for example, only simulation of such antenna take maybe 1 week, and result maybe not so good. And design such system is very important problem for us. Next, this is filter. I already said that filter is free third of, where is it? The third of power, third half of weight of our equipment. And here it is, design new small size and weight filter is very important problem for us. For example, one of the way which we cannot solve, and maybe you can help us, this is multimodal filter, which have resonator with not only one mode, but many mode. And maybe it can decrease size and weight of filter. And another problem is construct cavity matrix of this. No, I will not stay more details. If you are interested, after you will ask contact with me or with my colleagues and have details. Very, very important problem for us. This is high efficiency power amplifier. Он сам теперь переключается назад вот так. High efficiency power amplifier. You see now power of Нормально. Все хорошо, предыдущий. Okay. And you see, вы так, на это нажимаешь, now да, хорошо. Опять переехал. Now our base station is small cell, and small cell base station power is like 10 watt. MIMO base station, which include from such number of amplifiers and power from one. Я не трогаю, честное слово. Она переключает сама. And macro base station, very high power. Может, там слайд режим включен? Там слайд режим не включен случайно, а? Может, вы? Ну же, технические детали мне на английском что ли объяснять, в какую кнопку. Okay. And very important problem for us, this is digital predistortor. You see now power amplifier, я уже боюсь на них нажимать, потому что он сейчас переедет. Okay. And this is digital predistortor, which linearized power amplifier. You see previous power amplifier was work in linear regime in class A, so on. And efficiency of this power amplifier was like 5%. For example, 5% if you have 100 watt, 1 or 200 watt output power, it means that power supply must be very powerful. It's impossible, for example, in high tower, in install such low efficiency power amplifier. So now used very efficient power amplifier like like 60%, but it's very, very non-linear. And to linearize this power amplifier, we use digital predistorter. This is mathematical algorithm which find coefficients of predistorter to linearize it, and it works in real-time system and have no enough good characteristic, but problem the same. The resource of this digital power amplifier is very high. No, I already say about sanctions of United States. This is the same. Now size of ASIC. This is digital predistorter realized in ASIC, and now size and resources of this predistorter is very high. We need to decrease it. And it's hard problem, and not only here, but in future generation of our equipment. Next, this is passive intermodulation. Now you see, because of nonlinearity, power of base station is very high. So nonlinearity, not only power amplifier take part, but duplexer too. And if duplexer is nonlinear, the transmit power come to receive part. And in this case, sensitivity of base station decrease. And what does it mean? It means that your mobile will work bad, and base station don't receive signal. And this is again problem of nonlinear correction of system and build synthesis of nonlinear circuit. And this is how to say, maybe unite these two problems in mathematical way. This is build nonlinear model which correct power amplifier and correct compensate nonlinear distortion of passive intermodulation system. Here it is mathematical establish of such problem. No, I already said that design of ASIC, which realize of all these technical tasks, is enough complicated. And if you will help us design ASIC with minimum resources, resources is very... Да, вы мне где-нибудь за 5 минут скажите, а то я могу увлечься. А сколько я уже съел, а то у меня там много. Окей. Okay. And this is really a hard problem for us. Next, the baseband problem. Baseband, this is equipment which under RRU, and usually you cannot see it in the tower and so on. And here it is weight MMU, massive MIMO input-output system, and so on. First of all, this is system you see like radar, for example, for aircraft, but for another application. Here it is. Now you see we cannot use antenna array, for example, 1000 element, because it will be very expensive and you cannot pay for your mobile communication. So here it is a problem with problem with how make beam. Maybe only one sector, maybe only small time part of sector, and maybe sector will satisfy not one mobile. Here it is, every mobile will work, but here it is one beam at the same frequency work with this beam, this, and so on, and optimization of such system is a problem for us too. And if you work with it, help us too. Next, this is non-ideal estimation of channel. No error of channel. Okay. Next, non-ideal channel estimation. No, I will more fast because there are many problems here. This problem when mobile moving, for example, with high speed. No, now, for example, this is only in the road 100 kilometers, but at the same time, for example, in China, we have high speed train approximately 440 kilometers, and we need support it and work in this. And next part is optical algorithms problem. Here it is. Of course, we need to increase bit rate and of our signal. Okay, and here it is. We need number of. We can do it by increasing number of number of light mode in one fiber, or maybe increase bandwidth of light. This is one band, another, and so on. And problem here it is cross band too, and decrease signal noise ratio. No, this is modification of Shannon formula, and decrease signal noise ratio is very big problem for us, especially because again fiber is nonlinear system, and correct it is enough difficult task. And decrease noise and equalize it. This is maybe nonlinear Shannon limit, and if corrected, it will be much more efficient fiber transmission system. And here it is again, repeat and some details of fiber nonlinearity compensation, where distance between two fiber. No, for example, after Pacific Ocean, as I remember, like 4,000 kilometers, like this. So it increase noise very hot, and we need compensated. No, and do it, but all the same problem exists and need be solved. This is one of the formulation nonlinear problem. It's possible to make many linear and nonlinear system, but such approach not efficient. And again, we need to build good model with, no, here it is only two input because of, this is simple, because of small number of carriers, but now we work with 8 and more carriers. NFL and nonlinear filter which we use here is how to say, complicated and need to be optimized. Hard problem is compensation of non-linear distortion in fiber and laser and modulator. This is with non-linear system and decrease performance of our fiber optical system, and we need to linearize it and solve. Another problem is nonlinear Fourier transformation. This is poor mathematical problem. And I think normally I see chairman smile because it's a very hard problem. And if you will solve it, it will be fundamental breakthrough in peace. Okay. Okay. In what? Yes. Really so. No, and here it is all nonlinear question and problem, and so IC design problem. I've already said it, and this is very, very hard and difficult system. And unfortunately, you see now, no, for example, when I was student in my department, developed such system and so on. But after that in Russia, it was died, really died, and everybody used Xilinx, silicon, and so on, soft. But because of the restriction, we have no way to use it. So design such system is useful and very important. No, this is maybe some details how we think. Of course, to make such system more efficient than commercial system, which used maybe 20 years, is very difficult. But all the same, you see, I have example. Maybe everybody know HFSS system, which I see. Okay, and I'd like to say here that Yugoslavian Serbia University designed very competition program, and it was designed by university, very small, and maybe for our university it's possible too, because professors have many students, and main problem organize them, and this year they do some small part, next year maybe another people will do another, and so on. Open questions for this design. This is cut Yeda motivation and so on. Yes. Now I'd like to present Huawei scientists who will take part and with whom you can ask for more details questions. This is no, I think I have not so much time, so this is Tafentsov Konstantin and me and so on, and some words about Huawei. Huawei is a big company with big number of employees and have in many country region research center, and Huawei fabric-less organization, only design, only engineer. So it's very okay. And here it is. I will say about only small part of. У меня сколько? 0, ничего, понятно. Хорошо. Поэтому, so this is R&D center of Huawei in Moscow, and really this is communication with different Russian institute, and here it is. Main purpose of my speech. I ask for you, everybody, welcome to work with Huawei. If personally check vacancy in Handhunter and suggest your concrete contact and project. Welcome.
Спасибо. Уважаемые коллеги, у вас есть возможность задать вопросы. В преддверии, позвольте, я задам первый. Игорь, я обращаюсь к вам как представителю компании Huawei и в то же время как россиянин, который наверняка знает возможности российской индустрии и науки. Но меня интересует вопрос такого регионального характера. Как вы видите возможности взаимодействия Huawei с сибирским регионом, с сибирской индустрией, ну и прежде всего, конечно, наукой и наукой вузовской?
And now we have time for questions. So the first question was from our conference chair. This question was about future of this project, how to connect with this project, and I hope we will listen with the answer in English.
No, first of all, we already have contact with Siberian part. For example, we push Tomsk very much, and Huawei organize in Novosibirsk, in future in Novosibirsk, new department, new research center like this, and we are open to if you will contact with us and fulfill project with I already listened. It will be excellent,
Yes.
and I think no problem here. And you see, we can have different form of communication, include personal, but at the same time, I know that, for example, rector and vice rector very often against our personal contact with professor and so on. So it's now really it's forbidden in Huawei policy. And if we have contract for development of some project, we cannot take some person, professor, student, and so on from this university. But at the same time, у нас не работовладельческий строй. Если он сам захочет, мы открыты и принимаем.
Позвольте, я расширю немного.
If person want, he could work in Huawei. Okay?
Насколько я представляю, сейчас взаимодействие идет в основном в плане разработки программного обеспечения. То есть математика прежде всего Huawei интересует. А мне же просто по вопросу интересно, а что с аппаратным обеспечением? Есть ли возможности у российского бизнеса и у науки стать полезным в Huawei?
Да.
Please, can we have a conversation in English? I'm so sorry, but our conference is English conference. So first of all, the question was about the interest of our Huawei company, like what operation system does they have? Am I right? Yes.
You see, really, it's very sensitive questions for Russia. Because I have the same position as you. And we'd like, for example, design power amplifier in Russia, design ASIC in Russia. But unfortunately, Chinese colleagues very often think that level of such hardware design is low in Russia. And radio died together with Popov. Sorry. And I push very, very fast. But how? No result, unfortunately, because you see, for example, power amplifier of Chinese power amplifier, 60% efficiency, and in Russia, no at all.
Печально. Спасибо. Спасибо. Вопросы, коллеги?
Okay, we have a
Профессор
question.
Халютин.
Do you have any applications in aircraft equipment? Aircraft equipment, applications and researches. There are a lot of electronic devices.
I understand, but now no. You see, I don't say in my report, but now we have enough many research for car navigation, but for aircraft.
Maybe 5G network on aircraft.
No, you see, we have approximately 6,000. Oh, sorry. Approximately maybe 3 years ago, we have project with dirigible. I don't know how to, but it was died later. Yes. In the dirigible base station, but now it's dead, as I know, for aircraft. No,
Thank you.
mobile transmission and so on. Base station, fiber, data center.
Okay, thank you very much for your report. The time for question is over, and I think that it was very cool. Thank you.
Спасибо. Продолжаем наше пленарное заседание, уважаемые коллеги. Слово предоставляется следующему докладчику Александру Milekhin. Как увидеть невидимые и лайфхаки для ближнего поля оптической спектроскопии полупроводниковых структур. Наноструктур, прошу прощения. Так по-русски звучит вот так.
The next speaker is Alexander Milekhin. How to see the invisible of life hacks for near-field optical spectroscope of semiconductor nanostructures. Okay.
Okay, thank you very much for a nice presentation. First of all, I would like to thank organizing and program committees for giving me great opportunity to be here and present the results of our investigation in such wonderful place. Actually, I've been here about 30 years ago, namely in this place, and I can see drastic changes here, of course. So in Soviet time, it was small lake, a lot of garbage everywhere. Now you can see wonderful, brilliant place, which is equipped very nice.
Okay. Before starting my scientific part of the talk, I would like to present our institute, Arzhanov Institute of Semiconductors Physics. So the main directions of activity of our institutes are shown here. But before starting from this activity, I would like to say that our institute is, of course, not like a Huawei company. It's about 200 times smaller, and it involves just only about 1,000 employees, and here works a little bit more than 200 scientists here. We have 5 buildings which are located in Akademgorodok in the vicinity of Novosibirsk. And the main activities of our institute are investigation of atomic structure and electronic properties of semiconductor surfaces and interfaces, as well as quantum phenomena in low-dimensional semiconductor structure. Of course, we have expertise in epitaxial growth in technology, of, especially in molecular beam epitaxy. We developed also infrared photodetectors, thermal vision system, high-frequency transistor sensors, etc. And we have also setups for silicon-based technology, including silicon on insulator structures. And we also possess a knowledge in laser technology, quantum optics, and quantum cryptography. So one of the main activities is creation of new materials and quantum structure. Of course, we use standard bulky materials like silicon, germanium, gallium arsenide, and so-called 3,5 compounds, which are either indium arsenide or gallium or aluminum nitrides. And we create a whole set of semiconductors heterostructure, like multi-layered structure, silicon, germanium, 3,5 compounds, nitrides, and so on. We fabricate a lot of quantum structure, including quantum wells, quantum wires, or quantum dots, consisting of such set of materials. And one of the main achievements of our institute is the modern molecular beam epitaxy. We have about 50 machines which can produce different materials. So compact from Rieber company, which allows to synthesize 3,5 compounds, germanium silicon compounds, and other materials which can be used for various applications. We have also technological facilities for production of silicon on insulators, which are highly demanded in high-power electronics. And here, for example, the high electron microscopy image shows the crystalline silicon, which is embedded in silicon dioxide matrix. So, and our institute possesses a complete technological cycle from nanofabrication through device processing. We have post-processing machines and a lot of possibilities for optical diagnostics. In our institute, plenty of devices and systems were developed. We have thermal vision system which allows to see, again, invisible in infrared spectral range. We have developed photocathodes, bolometers, vertical cavity surface emitting lasers here shown in comparison with our device, which emits the light from the surface of semiconductors. We have infrared photodetectors, which were completely produced in our institute. We have produced semiconductor sensors which can be used for diagnosis of various diseases. And also we have produced spectral ellipsometers in our institute. Okay, To conclude, I would like to say that Institute of Semiconductor Physics possesses a high level of scientific expertise, first of all. We have plenty of modern scientific and technological equipment. Recently, we have established 2 young laboratories where all researchers are younger than 55 years old. And I would like to say that we strongly need motivated young researchers, including students and postgraduate students. And all these people are very welcome. So you can visit the website of our institute here and find the full information there. So now I would like to switch to scientific part of my talk, and it will be organized as the following. In the beginning of my talk, I would like to speak about principles and challenges of near-field optical spectroscopies, and mainly I will focus on so-called tip-enhanced Raman scattering. And then I will shortly describe the formation of semiconductor nanocrystals, which is often used in optoelectronics, these cadmium selenide nanocrystals. And I will show some picture which allows to characterize the size and the crystal structure of nanocrystals as well as plasmonic substrate. And then I will show some results of our experiment, namely tip-enhanced Raman scattering of semiconductors, nanostructures. And these nanostructures means molybdenum sulfide monolayers. This is brand new materials which are promising, which is promising for future applications. Then I will speak about spectroscopy of nanocrystals ensembles, which are deposited either on aluminum, gold nanocluster arrays, which are plasmonic structure, and commercially available chloride structures. And at the end of my talk, I will speak about the observation, visualization of single cadmium selenide nanoclusters. And finally, I will give the conclusion. So the principle of Raman spectroscopy was developed by Chandrasekhar Venkata Raman in 1928, and 2 years later he got Nobel Prize for his discovery. Simultaneously with him, Russian scientists, even a bit earlier, they found the same scattering, which was called not Raman scattering, but inelastic light scattering. So now there is a difference in English, Raman scattering, in Russian, inelastic light scattering. Yeah. This is because Mandelstam and Landsberg didn't get Nobel Prize. Okay, so how it works. The laser light comes to the surface of the sample and it scatters. Majority of the phonons, the scattered phonons, have the same energy as the energy of incident light. It means we have relay scattering. But important is that the very small part of the phonons have either a bit smaller or a little bit higher in the frequency position. So it means we have inelastic scattering. And this difference is the energy of some elemental excitation. For example, phonon or some vibrations in materials. And appearance of these features is fingerprints of materials. If we know the energy position of the phonons, we can recognize what materials we have. Okay, and since those time, since almost 100 years, the Raman spectroscopy became a traditional tool for investigation, a variety of materials, and we can determine a small amount of matter down to a single molecule. And the Raman scattering has found application in chemistry, biology, medicine, etc. But we are working in the Institute of Semiconductor Physics, and we are strongly interested in investigation of semiconductor nanostructure like nanocrystals, nanowires, nanocoulombs, two-dimensional materials, etc. Because they possess new electronic, optical, and phonon properties, they have already device application in light-emitting devices, photodetectors, memory devices. But Raman experiments provide just only average picture because quantum nanocrystal, this is ensemble, and all nanocrystals have different size and shape. And therefore, the information of single nanocrystals remains very rare. This is because of extremely low Raman signal, and it makes the nanostructure invisible. We cannot find the nanostructures, for example, on this surface. Therefore, our motivation is to find life hacks or to find approaches to investigate the phonon spectrum and finally visualize such nanostructure on the surfaces. Okay, for this, one of the opportunities to use so-called near-field optical spectroscopy, or namely tip-enhanced Raman scattering. How it works? So we have the cantilever or tip, atomic force microscopy tip. We should have atomic force microscope, and we illuminate the atomic force microscopy probe by the light through some system, through optical system, through objective. And we can illuminate this from down, from the up, from the side. So if we illuminate the whole area, so diffraction limit, you remember from the school, this is half of the wavelengths. So if we have, say, 500 nanometers wavelengths, so then we restrict it with the size of the laser spot up to about 200 nanometers. But important is that the light is strongly localized beneath the metal tip of IFM probes, and it strongly enhanced Raman scattering. Therefore, despite we illuminate the whole area, we get a signal from the tip almost. So therefore, we reduce the information or area from which we can get this kind of information. So the further trick is to use so-called gap mode tests. We put some kind of materials between plasmonic substrate, which can be, say, array of gold nanostructure and such metal atomic force microscopy tip. In this case, this is molybdenum sulfide. We can use such semiconductor nanoclusters, or we can use completely another plasmonic substrate, like shown here. This is commercially available chloride substrate, which is the set of inverted pyramids covered by gold layer. So if you put the material between the tip and plasmonic structure, we can have strong enhancement of Raman scattering, because in this area we have strongly enhanced electromagnetic field in the vicinity of Ter's apex. So therefore, strong or ultimate Ter's enhancement can be achieved. But there are, of course, plenty of challenges which should be resolved. First of all, this mechanism is observed just only for restricted numbers of materials. For example, carbon nanotubes, graphene, etc. Theirs depends on materials of sample, on the tip materials, and therefore all these issues make energy of the plasmon not well controlled. Okay, let's now switch to materials which we want to investigate. We have used so-called Langmuir logic technology for production of cadmium selenide clusters. How it works? We deposited layer by layer organic materials which contain the clusters of cadmium sulfide. Then we use thermal annealing and receive the freestanding cadmium selenide nanoclusters on the any solid surfaces. We can investigate in our institute by electron microscopy how the structure looks like. We can almost produce the very well organized number of cadmium selenide nanoclusters on the surface. We can investigate crystal structure. We can say that the size of nanoclusters is just 6 nanometers. Okay. We can produce in our institute also all plasmonic structure which we want. Here, example of scanning electron microscopy shown. Here we can see arrays of gold nanostructure. We can enhance the images. For example, this area, we can get such image, and if you look attentively, we can get a set of so-called gold nanodisk array on silicon surface. We have investigated such structure. We can change the size of gold nanodisk. We can investigate the absorption of these clusters. We know the energy position. So, and now the idea is to find the optimal condition when the Raman scattering can be enhanced. So we did such simple experiments. We have measured 1 monolayers of cadmium selenide nanoclusters deposited here everywhere. So we have monolayer of quantum dots deposited on the silicon structure. We measured spectrum from this area. We got nothing else but silicon, the information about silicon structure. But if you want to measure from this side, immediately we can get the signal from cadmium sulfide, cadmium selenide nanostructure. These peaks comes from cadmium selenide nanostructure. So, and enhancement factor up to 2000 was achieved. Now, we did all these kind of experiments, and later I will show you. But the trick is to create the plasmonic terse tip. So it means that the plasmon cantilevers or tip apex should be covered by metal. So we have developed special technology, and we use commercially available atomic force microscopy tips, investigate the initial tip. So we should know how tip look like. So then we deposited metals like gold, shown here, or silver, and got just only one single metal nanoclusters on the apex of the tip. So then we investigate molybdenum sulfide monolayers deposited on plasmonic structure. Now it is shown how it looks like. We can see even such folds which we can see from scanning electron microscopy image. This is atomic force microscopy image, and this is the phase. And we can see that these monolayers repeat the morphology of plasmonic structure. Okay, then we performed a comparison of TERS with Raman experiments. Raman spectrum is shown here, just small features which can be seen here. We can, I would like to pay attention, this spectrum is multiplied by 10,000. But if we approach the tip to the sample surface, immediately we can see the strong enhancement of Raman scattering. And this enhancement is a 5 order of magnitude. So we can follow the intensity now of this peak, and we can construct the images, Raman images. Okay. This is how the monolayer of molybdenum sulfide looks like in atomic force microscopy. If we measure Raman map of those modes which I showed, we can see such circles. It means that the Raman signal comes just only from the edges of the gold disk, like here. So it is expected that the locally electromagnetic fields is located the edges of gold nanoclusters. Okay, if you look attentively on each circles, it looks like that. We can follow the profile of this. We can see that intensity is changed drastically when we go from 1 to 9. We can also follow the frequency map. And if we will go from 1 to 6 here, we can see that intensity is changing. And it gives us information about, say, electron doping of these materials, or biaxial mechanical strain in these materials, or even sample heating by laser light. Okay. And now I would like just to show you an example of very high spatial resolution which can be obtained by Raman scattering. This is only one gold nanoclusters covered by monolayer of molybdenum sulfide. I would like to pay attention. This is just only 200 nanometers. This is less than 1/2 of wavelengths of the laser. Now, if we follow, if we construct the Raman map, it looks like that. If we overlap the Raman and IFM images, it looks like that. We can also try to go through this line, and we can see that intensity of signal just jumped in this area. And it means the signal comes from the area about 2 nanometers. Now, let's imagine we have 795 nanometers of excitation wavelengths. Diffraction limits is half of this. So it means this is about 400 nanometers diffraction limits. It means that according to geometrical optics, we cannot go below 200 nanometers. Now we can to do this. We overcame diffraction limits. So we can use optical microscopy and achieve resolution of 2 nanometers. For me, it's still amazing. Okay, we did the same with cadmium selenide nanoclusters deposited on the surface. We saw also similar images which appears from the edges of nanoclusters, and the spectrum are shown here. We can see a strong difference of signal recorded from this red area and close to this. So we have changed the plasmonic substrate and deposited submonolayers of cadmium selenide nanocrystal, and we investigated just this small area, and atomic force microscopy map of this area shown here. We investigated scanning electron microscopy map. And probably you can see that small balls here are cadmium selenide nanoclusters with a size of about 6 nanometers, and they are deposited here. We received a terse map of this area, and we can see that the signal from cadmium selenide nanocrystals occurs from these edges, so edges of inverted pyramids. Namely, in these edges, enhancement of local electromagnetic field is expected. So, and finally, we found the area where just one cadmium selenide nanocrystals is located, and we could step by step, point by point measure the Raman spectra. In this direction, we can see the feature which occurs due to cadmium selenide nanocrystals. If we go step by step, this signal is increasing and then decreasing. Okay, we can make vertical scan and also can see the same enhancement of this feature when we go in vertical direction. It means that we observed just only one cadmium selenide nanocrystals with a size about 6 nanometers by optical technique. So to conclude, I would like to say that in order to see invisible in optics, one of the great opportunity is to use so-called gap mode terse approach. So we should combine plasmonic substrate and terse active tip with optical structural parameters of semiconductor materials. So we achieved high spectral resolution, about 2 nanometers, and strong enhancement factor was demonstrated also. So I hope I convince you that we saw tierce enhancement of optical phonons in cadmium selenide nanocrystals with nanometers spectral resolution, and we were able to visualize just only one single cadmium selenide nanocrystals. And to finish my talk, I would like to say the phrase which I saw on the doors of one famous international laboratory which is dealing with optical spectroscopy. Life is hard. Spectroscopy should be easier. Okay, thank you very much.
Спасибо. Спасибо за то, что вы регламент выдержали. Коллеги, вопросы? Пока вы готовите, если позволите, несколько вопросов. Александр Георгиевич, поскольку вы начали с рассказ о институте, несколько общих вопросов. Скажите, пожалуйста, радстойкими полупроводниковыми приборами или структурами сегодня институт занимается?
Thank you for your report. Before we will hear the question from our guests, our conference chair asked you a question about what thing does your institute do? Can you tell about it, please?
The question was about radiation stable structural devices. Yes, of course, I would like to say that we are doing or we are producing materials for radiation resistant materials like silicon on insulator structures.
Спасибо. Спасибо. И следующий вопрос. Вот разрабатывая полупроводниковые, в конечном счете, приборы или структуры, которые вы передаете в индустрию, в промышленность, думаете ли вы о разработке спайс-моделей, так называемых? То есть модели, которые могут быть потом в симуляцию встроены уже у нас, у людей, кто использует эти полупроводниковые приборы?
Okay, thank you for your answer. And the next question, maybe you can translate the next question, because I think I can be not sure in words that here.
Probably I can translate, but I'm not quite with you. What kind of model you mean? Что вы имеете в виду?
Модель, которая отражает не только внешние характеристики, там зависимость, скажем, тока и напряжения, а нам бы хотелось, чтобы вот эти зависимости отражали и физико-технические свойства самого полупроводникового прибора и особенности его технологии производства. Они должны быть более глубокими и воспроизводить тонкие процессы. Сегодня мы пользуемся очень крупными моделями, которые сами инициируем, исходя из технических условий. Они довольно грубые, и нам бы хотелось, чтобы разработчики приборов, прежде всего физики, нам предоставляли более детальные модели. Сегодня они называются спайс-моделями полупроводниковых приборов. Но если нет, то я готов потом поговорить, потому что нам ваша помощь нужна. Мы здесь очень сильно буксуем. И это уже не вопрос, по сути дела.
Okay, I think that this discourse will be continued in Russian in their free time, but you can tell us a few words about this question and what do you mean?
You mean still in English?
Yes.
Okay, thank you very much. This is a really interesting question and highly important. So the modeling of devices, the modeling of future devices. This is enormously important question. For example, recently our institute has developed device which was checked by modeling, and actually it should work, but it wasn't, because modeling was done at room temperature, but device should operate at liquid nitrogen temperature. So, and this difference caused the enormous changes in the properties of the materials, and therefore device just simply didn't work. So therefore the correct modeling of the future devices is highly, highly important.
Коллеги, вопросы?
Are there any questions? Yes.
Do you produce transistor for mobile application? What is highest frequency and power? Maybe gain. if you produce?
Of course, we are not a plant. We are not a factory for production. Yeah, yeah. We develop in high electron mobility transistors first of all. Frequency up to 20 gigahertz, about 20 gigahertz. Yeah. I cannot say this parameter now. I should check.
Профессор Халютин, будьте добры.
Okay.
Do you have any researches in materials for electrochemical devices, for electrodes, for perspective devices that have more stability state while they work in applications? Thank you. Nanomaterials for electrochemical electrodes, for accumulators, for chemical application.
The question is either we doing something like this, yeah?
Yes.
Actually, the main activity of our institutes are semiconductor materials, yeah? And the electrolytes, this is the subject actually of other institutes, so something like solid state, Institute of Solid State Materials, so inorganic chemistry, and so on. I'm sorry. I should say that electrodes played even important role even in my talk, because this effect of enhanced Raman scattering firstly was developed or found on electrodes. And when people saw strong enhancement of Raman scattering of some analytes deposited on electrodes. Yeah, but this was just only like a tool, not the object of investigation, like a hammer, you see.
Okay, thank you very much.
The next question, Marina.
Hello, everyone. My name is Konstantin Afintsov from Huawei. So your presentation is very interesting, but I missed maybe what is the practical application for the such gold nanostructures you are evaluating? Maybe this question is related to the previous one. So what is the practical application of the gold nanostructures like you researched?
Yeah, I see that. I got your point. The idea to use plasmonic structure is just only to enhance Raman scattering by analyte. So we use this plasmonic substrate as really substrate. You see, the holder of some analytes. And these analytes can be semiconductors, nanoclusters, semiconductor, two-dimensional materials, chemicals, whatever you want. But the substrate is plasmonic substrate. This is a nanodisk array which gives enhancement of Raman scattering of something which is deposited on the surface. Yeah, just example. We have chloride substrate, plasmonic substrate, and on the surface we deposited cadmium selenide nanocrystals and looking for nanocrystals only. And plasmonic structure doesn't play any roles here, further roles. It gives enhancement and that's it.
Yes, but nanocrystal now is 2 nanometers, for example. Next step of TCMC fabric. Oh, sorry. This is no, now world first structure is future 2 nanometer and produced 2 nanometer ASIC and so on. And but
I see your point.
I understand that optical is important and spectroscopy graphy important, but for what is it?
Yeah. So, okay, you have 2 nanometers technology. That's fine, this is great. Where it is? Just in our mobile phones? No. This technology we have now in our institute, you see. We can do everything what we want.
This is 7.
Without, Huawei, sorry.
Yes, this is 7 nanometer. About 2, it's future, but 7 work.
Там, наверное, рентгеноскопия уже, поэтому.
Ну да,
Вряд ли опыта.
Конечно, конечно.
Okay, you have 2 nanometers device.
Yeah.
Can you say something about the crystal structure of this 2 nanometer
No, but
system?
it works.
No, it works. So this is Chinese way of doing.
Yes.
So we're doing everything and choose the best one. We're doing physics. You see, we want to understand what we have, why we have, what happens if you showed it. Yeah. So what happens if we change the crystal structure? So how the materials properties will be changed? So we should answer this question. And this is the subject of universities. Your problem is to create the working device. This is first of all. We're looking on the same from different sides.
Your technology, but I don't know how.
I'm so
Можно я
sorry.
более общий вопрос задам? Скажите, пожалуйста, вот оптическая спектроскопия, ее предел единицы нанометров, а дальше? Какая спектроскопия?
Optical spectroscopy has diffraction limit. This is half of wavelength. So 500 nanometers, diffraction limits 200 nanometers. Here I showed that we overcame this diffraction limit. We go to much smaller scale, up to 2 nanometers, you see. And we know information from the area of 2 nanometers by optical spectroscopy again. So we use optical spectroscopy, receive information like from electron microscopy.
Okay, I think it's a very interesting discussion. Okay.
It's impossible. I asked several times, give me opportunity to ask questions. Give me a microphone, please. Thanks a lot for beautiful talk. My name is Alexander Sevastianov. I am from State Research Institute of Neuroscience and Medicine. And you told that there are a lot of opportunities to apply your methods for medical diagnostics, but there are two kinds of diagnostic, in vitro and in vivo. In vitro means that you extracted molecules from organism, yeah, and analyze molecules outside of a live system. And in vivo, it's analysis inside of organism. Yeah, for example, your neighbor is tomographic center, and they analyzed brain structure immediately in a live patient. And how do you think your methods could be applied for in vivo diagnostic or not? Thank you.
Thank you very much. So, frankly speaking, I don't know, but I can imagine. So I'm not doing biology, I'm not doing medicine, but I know that this method is already applied for distinguishing RNA sequence. So it means that these methods became important in vitro. Yes, this means
you already extracted.
Yeah, I got your point. Yeah. So this is indeed in vitro. So in order to make in vivo, it's of course extremely difficult, but not impossible, I would say.
Your neighbor applied oxygenation. What? Use the microphone. That's a generation. Yeah, it's blood hemodynamic. Yeah, immediately in brain. It's possible to see both brain oxygen level dependency by means of analysis of spectrums of hemoglobin, yeah, with oxygen, without oxygen. But as I understand, it's another approach, yeah, for analysis of signals. Your approach is you didn't try.
I just showed just only one possibility of these methods of near-field optical microscopy, which combines atomic force microscopy tip and some objects. If we want to see in vivo, we should approach by the tip, say, to the skin surface. So this is quite, I would say, strange experiment. Yeah, but maybe it's possible to use another way, which called so-called aperture-less spectroscopy. In this case, we do not use such atomic force microscopy tips, but we use fibers which can approach to the surface. And in this case, such experiments becomes more realistic.
Okay, thank you. Thank you.
I think we should listen one more question from this hall, and after that we will listen questions from halls B and C, okay? I know that.
Thanks so much. My name is Rahmatul Franfaginovich. I'm a candidate for medical science, and I have some question about medical applications of your approach. No, it's obvious that we can use this method in laboratory tests, in biochemical blood test, an example. But tell me please about its availability in routine medical practice, its efficacy, and about its cost. So can we use it in daily medical practice, but not in special medical practice, like in scientific institutes and so on? Thank you.
Okay, thank you very much. I would say that this technique is still very, very modern. So, and it's difficult now to speak about routine application because there are only few laboratories in the world which can get similar experiments. And we are one of such laboratories in the world, I would say, you see. So therefore, routine experiments can be done only with graphene like materials like carbon nanotube, graphene, carbon species, etc. Yeah, sorry. So we should wait a couple of decades, I would say. Yes.
Okay, are there any questions in hall B? And in hall C? No questions?
Okay, thank you very much for your interest.
Спасибо.
Thank you.
Сейчас по нашему плану мы послушаем доклад Дмитрий Shcherbakov, представитель Государственного научного центра вирусологии и биотехнологий «Вектор» и Алтайского государственного университета. Представит нашему вниманию доклад на злобу дня, что называется, SARS-CoV-2 от молекулярной биологии к вакцинации.
So we continue our plenary session. We have some problems with our distance, yes, without a report from our Spanish colleague. We are waiting for him, and now we should change the reports between. So now the speaker, Dmitry Shcherbakov, SARS-CoV-2 from molecular biology to vaccines. You're welcome.
I listen some presentation, and I think you guys work with very difficult things. And now I think we will. I think I will tell you about more easy things. I think, but maybe not maybe, but more dangerous things. Okay, let's start. In this here you can see questions which we discuss in my presentation. First of all, current situation. Now, in whole the world, there are about 180 million cases of SARS-CoV-2 cases, and about 2% from this disease was dead. Maybe it's not so great number, but 2% it is about 4 million peoples, and I think it's huge numbers, of course. We all see about 2 or 3 views of SARS-CoV-2. Now, number of cases decline, but in Russia, situation opposite. In Russia now we have decrease number of SARS-CoV-2, and for my opinion, it's a very dangerous situation. Let me introduce SARS-CoV-2. SARS-CoV-2 is it has a RNA genome which encode viral proteins. First of all, non-structural proteins. Okay, non-structural proteins and structural proteins. Structural proteins, it's a proteins by which construct viral virion. As you can see on the surface on virion, there are 3 proteins: M protein, E protein, and S protein. S protein is the main surface protein. You can see here. This is S protein. Here you can see coronavirus life cycle. First of all, virus interact with cell protein, and next it encode genome material RNA, and next it start synthesize protein, and protein interact with new RNA and form viral virions, which go inside cell, and this process replicate more times. What about S protein? S protein is a main protein of this virus, because this protein interact with surface proteins of cell, and only this protein needed for virus for interaction and for infection of cells. Here you can see structure. It has two main parts, an N terminal domain, this, and C protein, C terminal domain. You can see here, C terminal domain form head of this protein, head, which interact with cell receptors, and C terminal domain form stalk. Stalk, it's a part of C protein which interact for membrane to fuse. Now we know that main, but not only, main receptor, cell receptor, is ACE2. This is receptor on cells which interact with S protein, and second receptor, neuropilin, here. In this slide you can see mechanism, interaction between S protein and ACE2 receptor. First step, interaction. Second step, cleavage, furin cleavage or other protease. And after this, start fusion between viral membrane and host membrane. And after this, genome of virus go to cell and start replication. Are there other SARS-CoV-2 receptors? In some articles proposed another receptors for SARS-CoV-2. For example, basegin, integrins, sialic acid, and TMPRSS2. But now it's clearly understand that SARS-CoV-2 use only ACE2 receptor. About TMPRSS2, I tell you now. In life, in real situation, for interaction of SARS-CoV-2 with host cell, ACE2 work only with complex of TMPRS2, and that is why this is not receptor but co-receptor of ACE2. And for complete infection process for SARS-CoV-2, we need two protein together, ACE2 and TMPRS2 is a protease which like furin cleavage as protein of SARS-CoV-2. Why I tell you about S protein so much? Because if we want have protection against SARS-CoV-2, we need immune response against S protein. Is a main protein, and only this protein using by SARS-CoV-2 to interact with cells. And if we will have antibodies or maybe specific T cells against S protein, we will protect from this virus. And of course, main part of S protein, RBD. RBD is a receptor binding domain, as a pieces of S protein which interact, only these pieces of S protein interact with ACE2, but of course it's interact in the complex. Let me tell you about start of outbreak. Start of outbreak was announced by WHO organization about 9 January 1212. This outbreak start from Wuhan marketplace. There first cases was detected. And next, as you remember, we see a lot of, not a lot, great number of cases. First in China, but next in whole the countries and in whole the world. Scientists think that scientists think that for SARS-CoV-2 there are two animals in which animals SARS-CoV-2 live. First of all, Paradoxurus hermaphroditus and Rhinophilus affinis. As you can see, these animals live in South China, here and here, and that is why I think if you ask me about which origin of this virus, is it natural or it was made by a human, I think this virus is natural origin. And some articles. If as you can see, this article is about discovery of novel coronavirus associated, and you can see here that Wuhan new coronaviruses is close to another bad SARS coronaviruses which was investigated in this region. Very close. Another articles, as you can see, this is 2018 year, and serological evidence of bad SARS-related coronavirus infection in humans, China. And you can see here, authors says, those results indicate that some SARS-CoVs may have high potential to infect human cells without the necessity for intermediate host. It means in 2018 years, some scientists propose that SARS coronaviruses can infect humans and has potential became global infection, global pandemic infection. That is why I think that SARS-CoV-2 has natural origin. Another articles, not articles, but another pictures from these articles. this region, and some people have antibodies against SARS-related viruses, not SARS-CoV-2, but SARS-related. It means that viruses related to SARS-CoV-2 circulate on the territory of China many years. And current situation. Maybe you hear about new variants of SARS-CoV-2 viruses and of course Delta viruses. Maybe you hear from news. Here you can see Delta variant. Delta variant, why so many interest for this variant? Because this variant cases with this variant detected not in the first numbers of this year, but it grows very fast. You can see here another variants decline, but for Delta variant there are very fast grow. Here you can see rate of mutation for coronaviruses, and I won't say that here this is S protein sequence. You can see more numbers of nucleic acid and amino acid substitution. This understand that virus SARS-CoV-2 evolute very fast, and speed of this process more higher than we can think. If we see on S protein and check region for mutation, we can see maximum this amino acid substitution on the whole protein. It means that this process not direct on RBD region, but whole of the S protein sequence. And now I want to tell you about vaccines. Why are vaccines needed? If we get virus, we became ill and maybe die. But if we prepare virus, special prepare, and inject in our organism, we became protection, antibodies or T cell, special T cell, and if virus, if virus attacked us, we will protect. Why is it so important? Because now in the whole world, not only in Russia, I see strange situation. People don't want to get vaccine, and it's very strange because we exactly know that SARS-CoV-2 is very dangerous virus, but people don't want to protect from this virus. For protection from SARS-CoV-2, scientists use different approaches. In this slide, you can see classical approaches these protein subunit vaccines, virus-like particles, whole virus vaccines, attenuated, inactivated, and new approaches, for example, viral vectors and nucleic acid vaccines. For SARS-CoV-2, scientists use both classical and new approaches, but in fact, we can see that in this situation, more successful is new approaches. mRNA vaccine. I think you listen about this vaccine is vaccine from Moderna or Pfizer or BioNTech company. How it work? How does it work? We have RNA in lipid code. RNA interact with cell membrane, and next from this mRNA is synthesized protein of SARS-CoV-2. Not all proteins, but as you now understand, main protein, S protein, spike protein, S protein. And next, this protein relies from cells, and after our immune system react with this protein, and after we have antibodies, or another way, we have T-cell response. T-cell response too very important for protection from SARS-CoV-2. And next platform is vector vaccines. Vector vaccines in Russia, Sputnik V is a vector vaccines on the basis of adenoviral vectors. In this approach, vaccine is composed from adenoviral capsid inside DNA, encoding spike protein. It interacts with cell, and next from DNA synthesize mRNA, and next spike protein, and next same process, induction antibody response or T-cell response. Not only these two platforms now using for development of vaccine against SARS-CoV-2. In preclinical development, there are a lot of vaccines. For example, on the basis of protein subunit, on the basis DNA, inactivated viruses, viral vectors, but these vaccines not so successful for prevention SARS-CoV-2. And I want to tell you about situation with real vaccine. It's situation for United States. As you can see, Pfizer mRNA vaccine and Moderna mRNA vaccine. Johnson & Johnson is an analog of Sputnik V vaccine, adenoviral vectors. For USA, more successful, of course, mRNA vaccine. For Germany, Pfizer, BioNTech mRNA, Moderna mRNA, Oxford, AstraZeneca, as you know, it is adenoviral vaccines, and Johnson & Johnson. For Latin American countries, another situation, they don't have so much money, and they buy vaccine from China. Sinovac is a China vaccine on the basis of inactivated SARS-CoV-2 viruses. and Pfizer and CanSino. Situation, how effectiveness are the COVID vaccines? In this slide, you can see Sinovac not so successful and protect only 50%. The more successful, of course, mRNA vaccine, Pfizer, BioNTech, Moderna. And second place, adenoviral vaccines. And what about effectiveness on the another variants? As you can see, vaccines, mRNA vaccine, Moderna, adenovirus, have some effectiveness on the new variants of SARS-CoV-2, but it reduces in some extent. And another approach for protection from SARS-CoV-2 is monoclonal antibodies. Monoclonal antibodies is not vaccine, but injection of protein antibodies to protect from to direct protection from virus. From start of outbreak, many companies start development of monoclonal antibodies therapies, but now it approach not successful because, as you understand now, SARS-CoV-2 very fast have very fast evolution, and this list of some experimental therapies on the basis of monoclonal antibodies, but no one on the market now. And some company start development drugs on the basis of compounds, chemical compounds, but as I know, no one have successful for treatment in clinical this disease. It's now all. Maybe your questions.
Коллеги, вопросы? Прошу.
Thank you very much for your interesting and very important report. But can you give any comments to the article that was printed in Novaya Gazeta? I mean, the article of Severin. So when he discussed the scientific, from the scientific point of view, publication about our native.
About which publication about vaccine?
Yes, about vaccine. But the
Which
publication,
vaccine?
I mean, our vector, Koltsova.
Okay.
Because we were waiting for this vaccine very much because it was not so dangerous for health. But after these two publications, no, I think that it's you can't recommend it. What can you say about it?
It's very, very difficult question. Very, very difficult question. For my own opinion, I think that vaccine from vector doesn't work. Totally doesn't work.
Dr. Shcherbakov, I think you say now about coronavirus very interesting information, and my question to you, what do you think as scientist finish COVID number 18? Nothing. Thank you.
This question is about finish of outbreak, finish about SARS-CoV-2 pandemic. It's a very difficult question too. I think that we will live with this virus all the time. Years. It not finished tomorrow or after a year. It will many years.
Sorry. I say only about COVID as pandemic, not about virus.
Yeah, I understand. I think it will be like for flu. We need vaccine every year or every 6 months, but it will be circulate in population in population, human population.
Thanks a lot for interesting talk. My question: how we can verify quality of vaccine? Yeah, now there are many different vaccines. Yeah, and we know that it is not only questions to biologists, to medics, but it's also political questions. Yeah, because you know that in Europe and USA, a lot of information that Russian vaccine is not working. Yeah, it's very bad vaccine. And we told, no, Russian vaccine is very good, American vaccine is bad. But which objective methods for verification of quality of vaccine we can apply? I vaccinated, yeah, but I have strong coach, yeah, and all people afraid maybe I am dangerous. Yeah, how we can check? Thank
you. Yeah, not easy question. Yeah, the situation is. Of course, we need for registration vaccine make procedure. First phase, second phase, and third phase of clinical.
Okay, I would like to check. For me, virus is dangerous or not? I am vaccinated, yeah? I know. How can I check?
Okay, I understand. You need to check your antibody levels. And if you have enough antibodies in your blood,
but maybe I will receive some new new modification of virus, yeah, and vaccine from previous stam will be non-effective to new stam.
You need to understand that if you have antibody levels in your blood, you also have T-cell response also.
I was vaccinated against OSPA, yeah, when I was a small child. Yeah. Now I have not antibodies to OSPA, yeah, but I have strong immune response.
Yes, you have memory cells.
Yeah.
Not only not only B cells, but T cells.
Sure.
Too. That is why if you have some level of antibodies in your blood, that is why you have a T cell response.
Yeah, I know what is immunology. Yeah, I have education in immunology.
Okay, I understand. Thank you. Марина, вот, а потом вам хорошо.
Tafintsov Konstantin, Huawei. So I have one question, but one answer was somehow make me disappointed about you. Maybe I did not clearly understand you, but what did you mean by that this vaccine doesn't work at all? What doesn't work, so it does not produce any immunity?
It doesn't work because it can work as platform. In vector vaccine, we have small pieces of S protein, so small it not correct. It cannot correct presentate immune system these pieces of S protein. From vector vaccine, we don't have immune response for protection because we can have. It's a situation is not if vector use normal, okay, classical platform for creation vaccine. It will be okay, but it use platform peptide vaccine, which doesn't work. We don't have any vaccine in the world on the basis of peptide vaccines. We don't have. First vaccine on the basis of peptide vaccine, and it doesn't work.
Okay, maybe we will discuss later, but let me ask the question I wanted to ask first. So, is that mean that this same vector platform can be reused for revaccination or not? That is my question.
How can we separate successfully edited adenovirus from some kind of white-blue reaction for bacteria, but for viruses? How can we be sure that we have correct adenovirus?
Rules of manufacturing in the pharmaceutical manufacturing so strong, so that when we produce virus, we don't have wild adenovirus. We have only a recombinant adenovirus, and it's not possible. It's not possible. The process is organized in this way that we don't have chance contaminate our vaccine with wild adenovirus. Only recombinant. Only.
Thank you. And one more little question: on which cells do we reproduce viruses, adenoviruses? How do we replicate adenoviruses?
Maybe your question about this this situation, yes? About replication in our organism?
Not in production.
In production? In production, it's a very difficult question. It's a difficult process. We have plasmid, which encode genome of adenovirus, and we have cells. We transform plasmid to cells, and next we have viral progeny from these cells. This process.
Okay, thank you.
Thanks for your talk. I have a question regarding living with the virus. So, how do you think? What's your opinion? What approach will be better or easier to apply for future modification of viruses? I mean, mRNA or adenovirus. What approach will be easier to use for new modifications? To reproduce or to manufacture?
I think I understand. I think future for mRNA platform. This is platform for future, for not only SARS-CoV-2 viruses, but for creation vaccines against another viruses and other maybe bacteria too. mRNA.
Полагаю, давайте поблагодарим за хороший, интересный доклад. Спасибо.
Thank you very much.
А сейчас последний доклад пленарного заседания. Его прочитает Антонио Луке. Тема доклада IEEE сегодня – как повысить свою карьеру с помощью профессиональной организации. Докладчик директор IEEE регион номер 8, Севильский университет.
And now the last report of our plenary session is a report that made by Antonio Luque. It's a distance report. IEEE Today, how to boost your career through a professional organization, IEEE Region 8 Director.
Okay, thank you very much. Good morning to everyone. Thank you for inviting me to be here in this conference, and congratulations for the success of the conference. Unfortunately, I cannot be with you in person this year for the reasons we all know, but I hope that we can meet in person anytime soon, maybe at one next edition of the conference. So actually, I was enjoying the previous presentation about COVID, coronavirus, and the vaccines. I got vaccinated yesterday, and I had a not very good night with some slight fever and so on, and headache. So I apologize in advance if I'm not as fresh as I should be. Anyway, my intention this morning is to talk to you a little bit about professional organizations, especially professional organizations in the field of engineering and in the field of technology, how the activities and the membership of such a professional organization can help us in our careers. And I, of course, I will use the example of IEEE. So I will be presenting IEEE. I will be describing the activities and how you can benefit from them. So the content of my presentation will be like this. It's a long content, but I will have a lot of information for you, and then we will have time for questions. So I will briefly start talking a little bit about myself so that you understand who I am and where I come from. Then I will talk about IEEE in general, the mission and the vision. What do the members of IEEE do? A little bit of history, and then some organization and numbers, and what are our plans for the future. And then I will talk about the different organizations and the different communities and activities that happen inside IEEE, like, for example, services we have for students, different communities. I will talk about the geographical regions, in particular region 8, number 8, which is where Russia belongs to. So we'll talk about the presence of IEEE in Russia, and then about this type of activities, conferences, publications, standards, education, humanitarian awards, all these activities, a little bit about the governance, and probably most important, what can you do? How can all this benefit to you, to any of you in particular? So I will leave the best of the presentation for the end, so I hope that you will stay with me until that time. Okay. So a little bit about, and at the end we will have time for questions, of course. So a little bit about myself, as I was introduced at the University of Seville in southern Spain. This is the second largest university in Spain, with 65,000 students of all areas. My area is engineering, but we also have law, medicine, we have sciences, we have social studies, so we have more or less everything. It's a very complete university. And my own research lines are on smart microsystems, smart sensors and systems, mainly, but not only for biomedical applications, and also to physical systems. I'm here today as an IEEE volunteer, something that I have been doing since 2002, so almost 20 years now. And during this year, 2021, I'm serving as the Region 8 Director. I will talk about Region 8 in a few minutes. I'm a member of the IEEE Board of Directors, which is the board who oversees all the things happening in the organization, Secretary of the Audit Committee, members of the professionals, European Public Policy, and a number of others. So I'm quite involved with the organization, so that's why I will try to pass to you, right, this passion for this, for such a great organization. This great, in my opinion, organization. So the idea is that all of us who work in research, all of us who work in engineering, in industry, who work in academia or in government, one of the most important things that we have to do is innovate. create new things to better serve the public, to better serve the society. And we cannot do this alone, of course, right? We need to collaborate with other people. So when we collaborate, when we network with other people is where this innovation really happens. And behind this type of innovation, behind this type of collaboration, there are always professional organizations that allow us to network, to partner, to make contacts with each other, right? So the idea at the end is that if we belong to such an organization, it will be much easier for everybody to have this push towards innovation, towards innovating in our work. So this is the main idea that I would like to transmit during this presentation, but of course there are details. So among the many professional organizations, I would like to talk a little bit about this one in particular that we call IEEE. So it's one IEEE here. And originally it standard for the Institute of Electrical and Electronics Engineering. Now it's more than electrical and electronics engineering, so we have other fields, but this is the origin and we still have the same letters there. And we are proud to be the world's largest professional organization dedicated to advancing technology for the benefit of humanity. And these two things are very important. And I believe that we should not forget any of them, right? So main purpose is to advance technology, to innovate, to create new things that are useful, but it's very important that this innovation must happen for a reason, and this reason is that it will benefit the whole of humanity. Right? So this is the final idea. It's not just advancing technology for the sake of advancing, but to benefit the rest of the people around us. So the idea is that we will create a global community that help this innovation, and through a number of activities like exchange of information, publication and conference, like the creation of standards to benefit industry, educational activities to promote the learning of members and of the society in general. If we are able to have access to this information, to this networking opportunity, to these benefits to members, then we will be able to progress in our final vision. Typically, the members of IEEE represent some of the best people working in technology in the world, so that's why the opinion and the view of IEEE is trusted, is a trusted voice when it comes to engineering, computing, technology in general, all over the world. And as I said before, this is started with electrical and electronics engineering, but now there are a lot of different areas. So we have biotechnology, nanotechnologies, we have aerospace, we have communications, we have ocean engineering, a lot of things which are related to engineering and technology, but not just electrical and electronics. It's a transnational organization present in 160 countries, whose headquarters are in near New York City in the USA. And what I believe is very important, this is an organization led by volunteers, by people who have other occupations, other professions, but we devote our time and our efforts to decide what IEEE should be, with the help of some personnel, with some people who are, some staff who are hired for the organization. So this is the general mission and vision, official mission and vision that was approved some time ago to foster technological innovation and excellence for the benefit of humanity, and we try to be essential to the global technical community. So all of us who work in technology, we belong to this global technical community made of professionals everywhere. Now, as I said, this is an organization composed by members, led by volunteers and composed by members, and the things that members do can be summarized here. So I will not read through all of them because you can read yourself, right? But we try to advance technology, of course. We create technical communities where to network with each other, we try to help in education, lifelong education, not just university or post-university, but the whole life. We help in career development, improve the careers of people. And of course, very importantly, I will talk about that, about ethics in the profession and about the awareness of technology by the public, right, to disseminate it. Very important for us is our commitment to diversity. So we approved a number of statements in the last years, right? So we understand that we need to have the perspectives of people with different personal, cultural, and disciplinary background. This means that everybody is welcome in the IEEE, and we take this very seriously. Our idea is to advance diversity in the technical profession and to promote an inclusive and equitable culture that welcomes everybody without regard to race, religion, gender, disability, or anything else, right? So this is very important that everybody feels welcoming in IEEE, and we are making very good efforts in the last year to make sure that this is the case. Now, I would like to briefly talk during the next couple of minutes about the history of the organization. So the organization is about 135 years old, a little bit more than that. So it started in the 19th century, 1884. At that point, electricity was not just some scientific curiosity, but it was something that was really being used, and it was really being employed by industry, by normal people in houses, and so on. So it became clearer and clearer that an organization that joined together everybody working in things similar to electricity was very much needed. When I say electricity, it was the power, electrical industry, but also other things which used volts and amperes and current and so on, like the telegraph, for example, which was able to transmit communication, right? So at that time, in 1884, a number of people met near New York and Pennsylvania, and they created this organization to promote the advance of electricity. And we have pioneers like Edison, like Graham Bell, who are among the members, the first members of the organization, and also very involved were companies like General Electric or Siemens, or Westinghouse, which were among the forerunners of the electrical industry, right? Then a few years later, it became clear that there was another technology which was based on wireless transmission after Marconi's invention. And then in 1912, the Institute of Radio Engineers was created. So there was electricity with wires and electricity without wires, and there's two competing organizations. But at the end, many people belonged to both because some things were between them, right, at the same time. So in 1963, both of these organizations joined and created this Institute of Electrical and Electronics. 18 years. At the beginning, it had like 150,000 members, and most of them living in the United States. And during the coming years, this was internationalized, right? Many people from other countries. So these are some people who were here from the beginning, like Hertz, Tesla, Marconi. We have Maxwell, of course, Maxwell's equation, and so on. And we have like a number of pictures here. This is one banquet that was used to be organized in New York. And we have Tesla, Sarnoff, and the Forest Alexanderson here. This picture. And this was the merging of both organizations to create what is now IEEE, right? After that, as I said, the organization was globalized and expanded to every country in the world, almost every country in the world. And by 2020, we have almost 400,000 members in 160 countries. Right, so here you have some numbers. As I mentioned, about 400,000 members. Most of them are now from outside the United States of America. Of them, about 100,000 are student members, and we are organizing different units. So, you see it's a complex organization with sections, chapters, student branches. I will talk about all these things in the coming minutes. And we have like 5 million documents that are served in our electronic database, more than 1,200 standards, 200 journals and magazines published, about 1,600 conferences organized per year, and 3.6 million, which are conference papers available when we increase by 200,000. Right, so these are some of the numbers. We have a strategic plan that goes up to 2025. We will try to drive global innovation, to enhance the public understanding of technology, be the trusted source, provide opportunities to development of the career, and create communities that advance technical. So this is what we will try to do. Something that I believe is very important is that all IEEE members need to abide by the IEEE Code of Ethics. And this is something that was very, very important when it was created, right, in 1912, because at that time, it wasn't clear that this was something that was needed, but some visionaries thought that it was important to make clear that everybody belonging to this organization shall behave in an ethical way in this profession. So we have like 10 parts of this code of ethics. I will not read all of them, but the idea that they are grouped in three parts. We try to be up to the highest standards of integrity, responsible behavior, and ethical conduct in professional activities. So we take very seriously the health of the public, improve the understanding of the implication of technology, avoid conflicts of interest, avoid any unlawful conduct. We accept criticism and improve our education, our competence, right? We also strive to treat all persons fairly and with respect, not to engage in harassment, and we try that make sure that this code is the basis of the work of the design, right? So this is very important, and when you sign up to become an IEEE member, you need to accept this code of ethics and behave like this in your professional life. Now, all these members who accepted this code of ethics, as I mentioned, are around 400,000, and here you can see that the number of members outside of the US surpassed the number of members in the US around 8 years ago. So now about 60% of the members live outside of the States. This is, in my opinion, very good. This trend is very good. It's a truly global and transnational organization, right? These members are grouped in different grades, and I believe that many of you could be interested in student and perhaps even more in graduate student. So if you have a degree in technology, but you are still pursuing some academic program, like for example, a PhD or a master's program, then you can be a graduate student, and this is very good because you will have access to everything at a discounted price like for students. And then we can also have professional members who are the members who have finished their degrees and are ready to go to the profession or already in the profession. And then when you are about to retire, when you have spent most of your life working in the profession, you can become what we call a life member, right? If you have reached the age of 65 years and has been a member of IEEE, so that the sum of these years is more than 100 years, right? The sum of your age plus the time you have been a member is more than 100 years. And then you become this life member, right? When you become a member, you have a number of benefits, like, for example, IEEE Spectrum magazine, which is here on the right-hand side. And this is an award-winning magazine intended to disseminate technology, more or less easy to read for everybody. But you can have special access to Collaboratech, the network, a virtual network to join everybody. You have access to the Center of Leadership Excellence, where you can have a lot of courses to learn, discounts in accessing the digital library, also discount attending conferences, opportunities to improve your education, mentoring. That means that you can be mentored by one senior IEEE member. And when you are a student, you get even more resources so that you keep updated with the information and with the developments in technology, right? And you are able to create these groups. I will talk later about the groups, which I believe is the most important benefit that you can get from it, right? So here we have a number of benefits of IEEE student membership. I believe that you will have access to this slide, so I will not read all of them, but you can attend advanced events. You can have a support in education. You can participate in student branches and create projects. You can get awards and funds. And you have specific publications like Potential. You can have access to scholarships, to awards, to a very popular context, which is called IEEE Extreme. You can have support to community service, so you can help others, have access to women in engineering, to groups in humanitarian technology, and so on. So all these things are available to all the members, and some of them also to the public in general. And as I say that, I would like to talk a little bit about how to group members, because 400,000 members is a lot of members, right? And we are grouping in different ways. So we have like two parallel organizations, one in geographical areas and one in technical areas, right? So these geographic areas, the world is divided in 10 regions, which itself, they are divided into more than 300 sections. So the section is the basic unit, and I will talk about that. And this is about geography, where the members are located. But depending on the technical areas that they work, they can belong to 39 societies, that are organized also in more than 2,500 chapters or 2,800 student branch chapters. So that's a lot of small sub-organizations where you can belong and you can network with people with the same interest and location, right? We also have non-technical organizations like, for example, the life members that I mentioned, groups to promote the presence of women in engineering, the young professional, people who are in the earlier stages of their career, people interested in entrepreneurship, on humanitarian technology, and so on. Right? So these groups also exist and are very useful. This is about this complementary technical and geographical structure. The technical part is organized in technical societies. Each of them is devoted to one particular area of technology, and sometimes they are grouped in technical concepts. And there are a number of them. There are 39 of them, and they are listed here. So I will not read all of them, but you can see there are things on circuits and systems, for example, on control, if you're interested on that, dielectrics, on power electronics, photonics. We have also in biomedical engineering, where electron devices, in societal implication of technology, ultrasonics. So there are a lot of topics here, right, that you can choose from. You can belong to 1, 2, 3, or as many as you like. And they sometimes they are grouped in councils, for example, on technology, on sensors, on superconductivity, or many other areas. Right? So everybody who works in technology can have a place. So they are also grouped in divisions, and here is the part of the organization. So this for your reference. Now we also have IEEE Collaborative, which is kind of the network where people can join together and exchange information. We try to create new initiatives that explore the cutting edge technologies, right? And we also have standards where standards regarding different parts of technology are developed in different work groups. And as I mentioned, we have what we call affinity groups, which are not related to technology, but other things like young professionals, like life members, entrepreneurship, the honor societies. We also have a lot of humanitarian activities intended to benefit people who are not in the best conditions, like engineering for change, groups of humanitarian technology, engineering projects in community service, and so on, right? And when it comes to geographic organization of the world is divided into 6 regions. 10 regions. Regions 1 to 6 are in the US, and they represent about 40% of the membership. And you and me, we are all in Region 8, which is composed by Europe and Russia, by Middle East, and by Africa. So as you see, it's very large region in the world, the largest region in the world in terms of area, but not the largest in terms of members. We have around 70,000 members, or around 18% of the total membership. Right. Now, within the regions, we have sections, student branches, technical chapters, and so on, where people can network with others who are close to them. When we look at the region 8, we have these 70,000 members in these 100 countries, and then 59 sections, and so on. We have more than 20,000 student members and a number of these units in this part of the world. And I'm sure you would like to know how Russia is organized in IEEE. I will skip these ones. Yeah. So the basic local unit is what we call a section, right? In many cases, these are the same as a country. So that it allows everybody who live under the same country with the same laws and with the same community to get together, right, and network with each other. But in some cases, some countries are so large and so wide, like Russia is, that only one section will be probably too few to cover all the countries. So there are several sections in the same country. So this is the case in Russia. You can see in different shades of green the parts that Russia is divided according to IEEE. And this is the Russia, Siberia section, and the Far Eastern subsection as part of it. This is one of the 3 sections that we have in Russia. One of them is called simply Russia. The other one is Russia Northwest around St. Petersburg, and then we have Russia Siberia. In Russia Siberia, there are 255 members, which is a good number, but we would like to see that increase. And there are 11 chapters there according to technical interest, and it would be nice to create more. 1 young professionals affinity group, and 6 student branches in different universities and colleges. So you are very much encouraged to join one of these chapters or student branches if you haven't done so. And of course, we are very open to create new ones to serve members who are in other places or who are interested in other technical areas, right? So one chapter is a technical subunit of one section, right? So for example, in Russia, you can have chapters in power electronics, and you can have chapters in circuits and systems. So everybody in the same area, working in the same field, belong to a chapter. And it's just 12 members as a minimum, or it can be 100 members. And the good thing about that is that local activities are organized through chapters. Right? Similar thing happens with student branches, which is a number of students in the same university. So again, we can provide support for students in the same university to get together and organize activities together. And there is possibility to get funding, possibility to get travel when that's possible, and the network with other people. And chapters on technical fields can be created, or affinity groups to promote in universities. That can also be. Now, a little bit about the activities. Again, I will not go through all of them, but there are more than 1,600 conferences held annually everywhere in the world, producing conference publications. And this conference can be organized like this one that you are attending today, can be organized by the different units that have. Here are some of the conferences that will happen very soon in Region 8. So we will have the African conference in Tanzania, September this year. We are having, we had already last week, we had Eurocon in Ukraine. Unfortunately, that had to go virtual. I'm sorry, just 21. About this. We'll have EnergyCon in Latvia. We'll have Milekhin next year in Palermo, Italy. We hope that that will be in person. And we are having, in Moscow, we are having HistorCon, the conference on the history of communications in Moscow, that probably will be also held in virtual. And we're also having the International Humanitarian Technology Conference devoted to humanitarian technology to be held in United Kingdom, in Europe, but held online. And we also have conferences devoted to students, to young professionals, and so on. So there are a lot of opportunities so that you can learn and you can attend anytime. We also publish about a third of all the technical literature in electrical engineering in the world, and they are the most highly cited, and we are very proud. All these publications, 5 million documents are accessible through the IEEE Explore digital library. We create the standards, which are the reference for industry in many cases, about 1,200 standards and more 900 under development now. For example, very common, very widely known standards is the 802, which is Wi-Fi. So Wi-Fi is one IEEE standard, and everybody is using these days. We provide continuing education, pre-college level, pre-university, university education, and then accreditation to universities. So there are a lot of opportunities. We have a program called Try Engineering, which tries to bring more students to engineering, to children, and so on. Humanitarian activities, philanthropic opportunities to benefit people. So we have projects in many places in Latin America, in Africa, in places in Asia, where people don't have access to electricity or some other technologies, and we are trying to bring them to these people. We have an awards program that recognize the best people in engineering profession, and we have here, you can see some of the names that were awarded IEEE awards in the past, and every year we recognize the best achievements in the field. As I mentioned, IEEE is governed by a board of directors, and then a number of subunits are there. So the organization is quite complex sometimes, so it has a lot of subunits, right? But one good thing is that it's very democratic, right? So all the members elect president every year, and they elect the board of directors, and they elect the IEEE assembly. So all the leadership in the IEEE is elected by the members, and this is a very good thing. And they organize all the leadership. They organize in different boards and different committees, right, that try to govern the organization. As I mentioned, the good thing is that it's governed by volunteers and for volunteers with the help of some staff, but mainly by volunteers. And this is a very good thing, so that all of us can have a say on where the organization is. So this is a very complex organization. I will not go into all the details, but as I said, the good thing is that this is volunteer driven. So I will go probably to the most important part of my presentation, and just to finish, what can you do? How can you help this organization and the good motivation that we have, the good objectives that we pursue, and advance your career at the same time? Because the good thing about volunteering is that you are serving others, you are benefiting others, but you are also benefiting yourself. And this is, in my opinion, this is the most important. So I would recommend everybody to volunteer, to devote part of your time, part of your efforts to do something for others, to help others, but at the same time, you are helping yourself. So all of us can have a say on what IEEE will be in the future. We can have our opinion, and we can share this opinion, and we can have a vote, or we can have a say, right? So we have created many things, and this came from volunteers. 27 years ago, Women in Engineering started. Humanitarian Technologies was created by volunteers. We created a committee for activities in Africa to help people there. We have created groups on artificial intelligence. All of this came from volunteers who had these ideas, and proposed these ideas, and they were adopted. At the end, the good thing is that if you serve IEEE in different positions, you acquire these leadership skills that they are very difficult to acquire in academia. So you will learn a lot of things that are very difficult to learn somewhere else, right? If you become a IEEE volunteer, you will play a key role in the future of the organization. And this is very good. You can participate in activities, expand your technical knowledge, gain some management and leadership skills, so not just technology, but also management. You will connect with others, and very importantly, you will give back to the profession. Right? There are many things that you can do to participate. So they are very small things that require just a few minutes or a few hours per week, or much more involved things that are almost a full-time job. But you can create meetings and activities, for example. You can organize conferences like the great volunteers of this conference are doing. And this is very rewarding. You can help others by mentoring some other students. Try to evaluate who deserves an award. Chair a committee which will decide something. You can create information and disseminate, or you can maintain a website. There are a lot of things. Some of them are very easy to do, and they will be a very good entry point. So try to contact your local partners and your local volunteers. That will be my final message here. This is a volunteer-driven organization, right? It's great if all of us are members, but when we make the most of our membership is when we get involved, when we participate, and when we can provide our time, our effort to the organization. This doesn't mean that you have to have a large dedication or a large commitment. You don't have to spend many hours. You can do small things, and they are also okay, like providing, reviewing a few papers, or creating some information and disseminating. This is also that anybody can do, and it's also very rewarding. And also, these days, everything is virtual and online, thanks to our friend, the coronavirus. So we can volunteer, we can participate without the need of much traveling. So we can be at this conference again without traveling there. We can spend time with other volunteers without the need of traveling. So I would really recommend all of you to be part of this great organization. My personal experience has been amazing in many years. And I welcome all of you, and I'm waiting for all of you to join us in the organization. So thanks for attending this conference, which is happening in Region 8. As I mentioned, this is the largest and the most diverse IEEE region. Thank you for being part of that. Here you have my email address, the URL for Region 8, and of course, I welcome all of you who are not members to join the organization, and I welcome all of you that are able and willing. So with that, I will finish. Thank you for paying attention, and I will be happy to tackle any questions that you might have. I hope that you have questions about things in the organization, things that you would like to know. So if I can help you, I will be happy. Thank you very much. I think I can.
Antonio, good morning. I have a question for you. Recently, I became a student member of IEEE, and I was surprisingly shocked by the fact that I don't have an access to all of the IEEE Explore articles, and I thought that this will be here. So what can you say about this situation, and will it change in time?
Yeah, thank you. This is a very common comment. So so in IEEE we produce this information. As I mentioned, this is 5 million documents, and it cannot be made available to everyone. So something that I didn't talk is about the finance of the organization. Of course, to run all these activities, we need funds, we need money, and this money typically comes from subscribers to the publications that we have, right? So typically, libraries in universities and companies, they subscribe to the publications, and they fund the rest of the organization. So that's why we cannot give free access to all members. So members have discount to access this Explore, but we cannot give for free. Most probably you will be able to access any paper in your university library. If you have access to a university library, most universities are subscribed to Explore, and this is where you will have access to all the papers, but it will be through university. As a member, you only have a discount to access all these papers. So this is something that, some people comment, and some people have comments on that. but unfortunately, we cannot do otherwise because we will not be able to fund the rest of the organization if we don't do like this.
Thank you a lot for your presentation. My question is, are there any opportunities for volunteers, for example, for chapter chairs, to travel on different conferences and meetings and different events?
Yeah, definitely. That's a very good question. So yeah, as I mentioned, chapter chairs is one. I believe chapters are one of the key units. I know that the structure is very complex, but chapters is one of the most important things because one chapter brings together people working in the same technology and living in the same area. So if you work, I don't know, in photonics, for example, and you live in a certain area, everybody working in photonics in that area will belong to the chapter. So it's very good to have local activities. But as I said, chapters also belong to one society, which is worldwide, right? So everybody working in photonics in Russia, Siberia will be in that chapter, but people working in photonics in France or in Brazil or in Indonesia will belong to chapters of the same society. And it's very common that chapter chairs of the same society join together at least once per year. And typically societies can fund the travel to this meeting so that the chapter chairs can exchange information, can exchange ideas about activities and so on. And this typically happens in conjunction with a conference, so that you travel to one photonics conference, following with sampling photonics. So you will travel to a photonics conference where you will meet other chapter chairs. So this is very common, and there are funds available for that. As you know, these days we cannot travel much, but when we go back to normal, this will be very common. So that's a very good question, and I would definitely encourage you to volunteer as a chapter chair.
Thank you for your answer, Antonio. Do we have any questions? Thank you very much. The questions are over.
Thank you very much. Enjoy the rest of the conference.